Hello students and welcome back to my channel. This is the Sports Nutrition series of videos, and today we're going to continue by talking about the macros for the athlete. Expect to learn in this video the macronutrients metabolism as well as the nutrition for the athlete, starting by the carbohydrates. Hi, my name is Tommy. I am a human nutrition student and researcher at the university. What I do in this type of videos is to synthesize my classes so then I can explain and teach you the best and most valuable information you need to know. So let's begin this video by talking about the human metabolism. So macronutrients, metabolism in the human body. We have the macros that we ingest, the carbohydrates, fats and proteins that we're going to use to create ATP, which is the energy we're going to use for the exercise. And to do that, we have to eat. So there we can differentiate between the absorptive, digestive or postprandial state and the post-absorptive state, which there is no absorption and we use the reserves. It's also called the interdigestive. So let's take a look at the absorptive first. Here, when we eat, the liver, the muscle and the fat are going to benefit the most because the liver is going to take those monomers and create new structures after filtering them. The muscle will have the glucose to create new energy and glycogen, and also the protein for the muscle protein synthesis to repair. And the fat will also benefit because the excess of glucose, for example, will feed the fat. Carbohydrates, proteins, and lipids. The carbohydrates go through the liver and then to the rest of the body. So they go through the portal circulation to then the systemic circulation. The proteins do the same. But the lipids go through the lymphatic system first, and they do not pass through the liver directly. So they go to the lymphatic system, then to the systemic circulation, and then to the liver. So after that, we have a glucose metabolism, fat metabolism, and a protein, indeed amino acid metabolism. And if you want to know more about metabolism, I have a whole series of videos in which I cover the metabolism of the human body in much more detail. On the other hand, in the post-absorptive state, there is no absorption and we use the reserves. Indeed, fasting is a prolongation of the post-absorptive state. And in this state, there is the gluconeogenesis, so the creation of new glucose, and the glycogenolysis, so the lysis of the glycogen. There is also the alanine cycle, and this is to get the amino acids converted to glucose. And this is a part of the gluconeogenesis indeed. We do this to raise and maintain the glucose levels in the blood. The gluconeogenesis indeed is mediated by glucagon, the counter hormone to insulin. In this state, we also have the fat mobilization, which will increase the beta oxidation and maybe lead even to ketone production. This tends to occur during fasting. And again, if you want to know more about biochemistry and metabolism, I have a whole series of videos talking about that in much more detail. You can find it right here. Moving on, we have to take a look at nutrition for the athlete. This is the exercise fatigue. And the fatigue is indeed feeling tired with a decreased performance. If there is not a decreased performance, it's just a feeling of tiredness. It occurs when there is low glycogen and low basal glycemia. When there is an increase in central fatigue, this is the mental fatigue in the central nervous system. There is a lower hydration and a lower basal sodium, and maybe even correlated with gastrointestinal discomfort. So glycogen depletion. Each muscle cell uses its own glycogen. Therefore, there is an individual fiber depletion. At higher intensity, there is a higher glycogen depletion. And you can train to oxidize more and acidify less. To oxidize more means to use the glucose correctly, which is indeed in the aerobic metabolism. Do you remember that? Using the aerobic pathway, the Krebs cycle. And to acidify is to create lactate from glucose using the anaerobic pathway. So, as I was saying, the perceived sensation of exercise is the central fatigue. And lower glycogen is correlated with higher fatigue. And this increases the perceived tiredness, even though the performance remains the same. Again, if there is not a decrease in performance, we cannot call it fatigue. It can be called central fatigue, but to be more specific, is the perceived sensation of exercise. And now let's talk about carbohydrates. So macros in athletes do not usually change. They simply eat more and perhaps higher carbs and less fat. More calories are expended training than competing, but that depends on the sport. For example, if you train to run the 100 meters, the competition is only 100 meters. but the training session is much longer than that. On the other hand, if you run a marathon as a competition, your training session is probably shorter than 42 kilometers. Knowing that 60 to 70% of the diet should be carbohydrate. This is recommended because higher carbs equals higher glycogen. And as we saw, glycogen is fundamental for a good performance. An excess in carbohydrate is converted to fat though, so we have to find that sweet spot. And you have to know that glucose can create amino acids, and from glucose we can also create lipids. From amino acids we can create glucose, this is the gluconeogenesis we explained, and from amino acids we can also create lipids. But from lipids we can only create glucose, and only if we are talking about triglycerides. And it's not because of the fatty acids, it's because of the glycerol molecule, because 2 glycerols can create 1 glucose. So when talking about carbohydrates for a diet, we have to mention the glycemic index and the glycemic load. They are very 2 different concepts. The glycemic index is the speed at which the glucose in the blood will raise, and the glycemic load is the amount of carbohydrates per 100 grams of that food. So for example, white rice has a high glycemic load and a high glycemic index. Why is that? Because 80% of that rice is carbohydrate. That means it has a very high glycemic load, but it also has a high glycemic index because it raises the blood glucose levels very quickly. On the other hand, we have an example with the watermelon, which has a tremendous glycemic index. So it raises the blood glucose levels extremely quick, but the glycemic load is very, very low. So as you can see, we have to play with these 2 variables. The pre-competition meal recommendations nowadays for athletes are the following: 150 to 300 grams of carbohydrates, that equals 3 to 5 grams of carbohydrates per kilogram of body weight. Low to moderate glycemic index, because we don't want a huge spike in insulin. Usually 2 to 4 hours before the exercise to have enough time to digest it properly. And low fat and fiber, because we don't want to slow down the digestive process. And in athletes with pre-competition jitters, it's best to use carbohydrate-rich drinks to avoid the nausea, because many athletes can't really eat, but they still need the glucose and the glycogen to perform well. So drinks are recommended for them. Some athletes also take glucose 30 to 60 minutes before the test, before the competition. But this can lead to a possible rebound hypoglycemia, because when you spike glucose, there is also a spike in insulin, which will lower the glycemia, leading to a possible hypoglycemia. So to avoid that, because having a hypoglycemia before a competition is not good, we have to adjust the diet with lower glycemic index carbohydrates to avoid that insulin spike, and adding fiber. A little bit of fiber will also lower the glycemic index. Controlling the amount of insulin is released and therefore lowering the chances of hypoglycemia. Talking about hypoglycemia, you have to know that the cyclist bonking is indeed an hypoglycemia. This occurs when the glycogen stores are empty and we are run out of glucose. And because the athlete is not metabolically flexible to be able to rapidly switch to the fat metabolism to continue the exercise. The solution to this, nowadays they use intra-training carbohydrate intake. That's why a lot of athletes consume glucose gels during competitions. Is it the best thing to do? Well, nowadays there is a debate on that, but for now they keep doing it because it works for them and there is no apparent interest in trying another thing. On the market there are also available some drinks that contain 6 to 8 grams of sugar per deciliter, and these are used by the athletes to save that initial glycogen consumption. So instead of relying on the glucose they already have in the body, they use these sugar drinks to use that external glucose first. Okay, this is it for this video. I hope you understood everything I said. If you didn't, there is a comment section down below. Don't forget to like, subscribe, and turn on the notifications so you get notified every time I upload a new video. If you find value in this, please share it to your friends and family to spread this knowledge to them as well. Thank you so much for watching, and I will see you in the next one. Ciao! Hope you enjoyed.